Storage tanks for organic liquids, inorganic liquids, and vapors are used in a wide variety of industries. The vast majority of storage tanks are designed and developed in accordance with the American Petroleum Institute's API 650 standard. Such tanks come in a variety of sizes, ranging from 2 to 60 meters in diameter or more. These are often placed within containment basins to control spillage in the event of a tank break. Petroleum production and refining, petrochemical and chemical manufacture, bulk storage and transfer activities, and other businesses that consume or produce liquids and vapors are all sectors that use storage tanks. The most common types of storage tanks used to store liquids are as follows: fixed roof tanks, external floating roof tanks, internal floating roof tanks, domed external floating roof tanks, horizontal tanks, LNG, liquefied natural gas tanks. A fixed roof tank is the least expensive method of the widely common tank design to build, and is generally considered the bare minimum suitable equipment for storing liquids. A typical fixed roof tank consists of a cylindrical steel shell with a permanently attached cone or dome-shaped roof. Although modern storage tanks are often completely welded and intended to be liquid and vapor tight, older tanks were often glued or bolted together and are not vapor tight. A breather valve, pressure vacuum valve, that's often placed on many fixed roof tanks, enabling the tank to function at a very low internal pressure or vacuum. Because this valve prevents the escape of vapors even when the temperature, barometric pressure, or liquid level varies only little, the emissions from a fixed roof tank may be significant. Furthermore, gauge sample wells, float gauges, and roof manholes allow access to these tanks and may be sources of volatile emissions. Fixed roof tanks are typically used for the storage of less volatile substances like water, fuel oils, and some chemicals. A common floating roof tank is built out of an open-topped cylindrical steel shell with a roof that floats on the surface of the stored liquid, rising and falling in lockstep with the liquid level. A floating roof is composed of 3 components: a deck, fittings, and a rim seal system. Floating roof decks are constructed of welded steel plates and are available in 3 basic configurations: pan, pontoon, or double deck. Whereas many pan-type decks are in use today, the current trend is toward floating pontoon and double deck roofs. Manufacturers include a variety of variations on all these main kinds of floating decks, each emphasizing a different characteristic, such as complete liquid contact, weight-bearing capability, roof stability, or pontoon arrangement. Except for the tiny annular gap between the deck and the shell, the floating deck covers the liquid surface. The deck may be in touch with the liquid or float immediately above it on pontoons. External floating roof tanks are supplied with a rim seal system that runs around the circumference of the roof and touches the tank wall. Even as roof is lifted and lowered, the rim seal system moves against the tank wall. Likewise, the floating deck has components that pierce the deck and perform operating tasks. External floating roof design limits evaporative losses from stored liquid to the rim seal system and deck fittings. Internal floating roof tanks are classified into 2 broad categories: tanks with a fixed roof that is supported inside the tank by vertical columns, tanks with a fixed roof that is self-supporting and without internal support columns. The fixed roof is not always without holes, but it does cover the whole of the vessel's open plan space. Fixed roof tanks converted to internal floating roof tanks generally have a self-supporting roof, although external floating roof tanks converted to internal floating roof tanks often have a self-supporting roof. Tanks may be built with either a fixed roof or an internal floating roof. Internal floating roof tanks have a fixed roof and a roof that floats well above the liquid surface, contact deck, or is supported by pontoons several inches above the liquid surface, non-contact deck. An internal floating ceiling that rises and lowers with the level of the liquid. Floating roof tanks, primarily used in the petroleum industry to store volatile liquids like crude oil, gasoline, and other petrochemicals. Domed external floating roof tanks contain heavy-duty decks as well as a fixed roof on top of the shell. Fixed roofs often lead in domed exterior floating roof tanks. The purpose of the fixed roof isn't just to serve as a vapor barrier, but to block the wind. Another very popular kind of fixed roof is a self-supporting aluminum dome roof, which is fastened. They are fluidly ventilated, much as the internal floating roof tanks. For exterior floating roof tanks, the deck fittings and rim seals are essentially similar. Horizontal tanks are made so that the length of the tank is not more than 6 times the diameter to guarantee structural integrity. Most typically, horizontal tanks are fitted with pressure vacuum vents, gauge hatches, and sampling wells. Horizontal steel tanks are used above ground and underground. Underground tanks may be cathodically protected to avoid corrosion of the tank casing. Cathodic protection is performed using sacrificial anodes linked to an impressed current system or by employing galvanic anodes in the tank. But most refined petroleum products include corrosion inhibitors that render internal cathodic protection ineffective. Horizontal tanks ideal for storing gases such as propane, butane, and ammonia at high pressures. These tanks are commonly found in industrial and chemical plants. An LNG storage tank is a particular kind of storage tank used for the storing of liquefied natural gas. Storage tanks may be placed on, above, or in LNG ships. LNG storage tanks do have the capacity to store LNG at an extremely low temperature of -162 degrees Celsius. Each LNG storage tank has 2 cylinders, one with LNG and the other with insulating materials. Containment tanks are the most frequent tank type. Without leaking, the pressure and temperature in the tank will continue to increase. LNG is a cryogen and is preserved liquid at very low temperatures. When the pressure is maintained constant, the tank's temperature will not change. This is called auto-refrigeration.